represent Distributech 2023, one of the sponsors of these interviews, and these are interviews with thought leaders from around North America and the globe. Our sponsors are H2Scan. H2Scan is the leading sensor manufacturer for hydrogen sensing in a lot of different applications, in transformers, in battery room safety, in processes in safety, in industrial, and in the future hydrogen economy. So I want to thank our sponsors, and I want to thank all of our guests, and I hope you enjoy this interview. My next guest is John Brett. He is the president of Delta X Research. President, are you CEO of Delta X?
President and CEO, yes.
President and CEO of Delta X. See, I almost got it all in there. But I've known John a number of years, and we've got a lot to talk about Delta X Research, but we've got a lot to talk about in the industry. But first of all, tell me a little bit about your background and how you ended up in the industry, how you ended up as President CEO of Delta X Research, and a little bit about the company.
Well, that's a long story, actually. But
well, I know it is. We'll talk about that one, but let's do yeah. Okay.
But how I got at Delta X Research, and my background is I went through the Canadian Royal Military College, which is like the academy system, got my EE, spent some time in the Canadian Navy, and they saw fit to specialize me in command and control systems. Okay. But I spent 5 years doing that and decided I wanted to come out and do something else. And I ended up going from a very large organization to a very small one, which was Jim Dukarm's first company of 10 people who did a lot of leading edge software development on behalf of other companies. Notably, that company did Doble's first version of software, DTA.
I did not know that.
Jim is the architect behind DTA 1.0. And so that's how Jim got into the industry. And then, Jim saw fit to say, hey, I need to do some consulting. Running a company isn't really my thing. But he got into gas and oil analysis on his own. I went off and did some other things. I worked for a Rockwell Automation affiliate, so factory automation, command and control systems fit there. And then I met the founder of Tantalus, which is another vendor on the floor. He's a friend of mine, and he asked me to help build Tantalus from the ground up, so I helped do that for 11 years. Did a couple of years of consulting, and then in 2014, Jim calls me out of the blue and says, hey John, I'm a victim of my own success. Can you come and help? And one thing led to another and says, okay, we need to build this company. And John, could you please be the leader? Because I know that my thing is math and building a company is not for me.
Yeah, he's brilliant, isn't he?
He is. I mean, what makes him smart is he knows what he's not good at. And, I'm really privileged and blessed that he's put that trust in me. And we've come a long way since then, and we're doing well.
Good, excellent. We're going to get back to Delta X Research in a little bit, but one of the things I like about you've had the experiences, but you're also a student of the industry. And last year we went to these conferences. I think I talked to you too. That was with IEEE PEST&D, wasn't it? Yeah. Everything we heard was supply chain. That was it. It was like nobody could focus on much of anything else other than supply chain. A little bit of labor problems, staffing, things like that, but it was there. We haven't solved the supply chain issues, nor will it be solved easily and overnight. But we're on the way to doing that. There are a whole bunch of other challenges and opportunities, and in the industry. You've been around Distributech now for a day and a half. You're a student of the industry. What do you think some of those major challenges are that a utility is going to have to go through here in the next 5 years?
Well, you made a really great observation as we were sitting down, in that we're not seeing big flashes of IoT here or big flashes of drones, which are very useful tools. They haven't gone away, but I think people have come to realize, there's some really fundamental. You got to roll up your sleeves and get down to the hard work of implementing those things. And when I was helping build Tantalus, which is about basically automating the distribution system out to the customer, to me it was like a command and control system. Yeah. Right? And I remember the phrases back then is, this is where the term smart grid came around. Well, the grid was always smart, right? It's just how do you get that connection, that intersection where the technology becomes economical, hits that economical point where you can automate further. And we've been getting there and getting there and getting there, and it continues to evolve. And so I don't think it's a major hurrah, the whole world's changing upside down. Except for distributed generation, and that's quite different. But in terms of actual straight control and automation technologies, or concepts, let's say, the technologies have improved. There's nothing really new there. It's now how do we implement it? And that's the hard part, because the challenge for us is not so much the idea of automating it, but it's the volume of data. How do you pull that all data? And just 20 years ago, how do I get all this data into one place?
Yeah.
How do I make sense of it? That's not new, right? The IoT, all that enables is getting more data so you can get more confused, right? And so you got to figure out how you make sense of that. What I am seeing is, people have become overwhelmed, and and I heard of one large utility hiring a consultant, didn't work out, and they're sort of step back and say, let's reassess this. Okay, let's see what we can do with what we got first. Make better use of what we've got, and then take the next step in an incremental approach. And it's like the utility industry. If you know software development processes at all, it's like the utility industry is learning their own version of Agile.
Yeah, okay. There's because I can see them reconcentrating of work with what we've got, but at the same time, the utility industry has always been, I will look at the new, but it's got to be proven. Well, how can it be new and proven? It's got to be proven, or it's got to be new. But I think the reluctance for people to try new things, even though they saw some of the new shiny type things, I think that kind of looking introspection has kind of opened up a little bit. Almost every utility has an innovation group, right? If you want to get in, don't go to the substation management team, don't go to the generation team, go to the innovation group, because they're looking at the future. They're looking at how are they going to integrate all of these things. The challenges on a utility are greater today. They have 50 states that, for the most part, do capital spending based rates, right? Yes. Not performance based, capital spending based. Well, capital spending is not necessarily what a utility needs to do anymore. Right. They have to take care of what they got. And by the way, you can't get a new transformer because it's 3 years out. So the point being, there is a more of an open environment to look at things and take a chance, test them out, beta them, model them, see if they can do it. And then other people are much more quicker. I call it the new be first to be second.
Yeah. We used to refer to it as racing to be second.
Yeah, racing to be second. So be first to be second, the same kind of a thing. A lot of that's happening, which are exciting times for the industry, because it's not as staid and unsexy as it has been. I mean, people are now saying, oh, wait a minute, I can help decarbonize the planet. Maybe I do want a job in a utility, that kind of a thing, right? But there's a lot of innovation taking place within utilities. You work with utilities, you get to see a lot of, or hear about a lot of innovation, right? Address that. Where's it working well, and where you can't name the utility, but you can say, oh my gosh, I got an example of where that fell flat on its face. Ratepayers were ticked off, right?
Yeah. Well, can I pick one? Where is it working well, and where did it not work so well? Well, again, I'll say the not so well is, I'll deal with that one first, because that's a fairly fresh example, is getting caught up in the promise of AI and machine learning solving problems.
Oh, that's great.
Right, and it drove us a little bit, because as you know, we lead with science, right? And it drove us a little crazy because, we know that AI is a very big, complicated machine. And one of our customers implemented a big machine learning platform for health and risk management. And, fortunately, that customer very much believed in what we did, okay? And it was a really interesting exercise, because they put this solution in, and they got okay results. They got data from all sorts of sources. And they were using raw, we do dissolved gas analysis. So they were using raw gas data too, but they really couldn't make a lot out of it. And then, what we've done is we got with first principles science, we create some different results, that aren't standard, and all of a sudden we input that, and the feedback we got is their whole AI platform was elevated by the fact that we got results that were science-based actually fed into it. Not raw data,
Right.
but results from a different tool that actually interpreted the data more correctly. And I think that's why you're not seeing as much AI in MR, because they realize the hard work and the time it has to go in, and it's not just a panacea for pulling this data in and making sense of it.
And you hear a lot more about machine learning actually taking hold and taking place now, which is a part of AI, but it is a part of AI that I think is more historically based. Hey, we can, and that you hear a lot more people having confidence in machine learning, but you don't see a lot of machine learning people here. It's kind of an interesting phenomenon. They want to get there, but they got to start with machine learning. Make sure you take your historical data, do some extrapolation, and as engineers, we interpolate, we extrapolate, and we take data and we make sense out of the data, but we don't try to create some magic box that takes a whole bunch of data and ships it out there. Yeah. I want to. You mentioned a couple of times we, being Delta X Research. From the time that you've gotten there to where you are now, what are the changes that you brought about at the company? So describe Delta X Research and the value to the industry as it is today.
Well, a number of things. When I joined, it was 3 to 4 people, 3.5 people, and the principals, the people involved. And they were doing a great job building relationships. And Jim, the founder, he's a PhD mathematician. And the lore is, he worked from his basement in the Star Trek pajamas, and he was always accessible, right? And he was.
Yes,
I mean,
right,
we go by scientific, easy, independent. Yeah. And I'll tell you, the easy part is the hardest piece for me to institutionalize in the company as we grow. So we're 14 people now. We're trying to fill 4 new positions, But we're committed to that culture that Jim created, that built trust, is because the engineers liked the fact that they could talk to the inventor of the solution. And we didn't have a black box. Jim would explain to them, here's the logic that went behind that particular decision that the software came up with. And so the hard part for me is building that into the culture of the company. How do you institutionalize that and get the whole company, all the people to embrace it? I'm really, really lucky. I mean, it's a great privilege that, to do this, because Jim has given me an opportunity to build it from the ground up and build the culture from the ground up, where we have a serving sort of attitude that says, okay, that's what we're here for. We don't try and, lock customers away from their data or anything like that. It's open, and our job is to make sure we can provide the best interpretation of the data. So it's good quality information that is derived from it, so they can make the best decisions on the data they have with confidence. I don't know, did I answer your question?
No, that answered the question. Now, now I got to know, where are you going?
Yeah, well, right now the majority of the large utilities use us. We're really privileged.
You're the big dog in that market.
Yeah, really narrow piece of what we do, but it's an interesting place there.
Marketplace,
it's a big marketplace. And so what we're doing right now, and I don't like the IoT phrase, but it's all about the automation. We have an add-on called Monitor Watch that takes the data from monitors. And what we've learned recently.
Monitors?
Yeah, because we just do software. Right. We're independent that way. That's the other piece. That's the last piece. Scientific, easy, and independent. Of course, we have a bias towards our own software, but we'll work with any device. We'll work with any lab, any service company. Happy to do that. But there's a company here on the floor called H2 Scan. They make a hydrogen sensor.
They're one of our sponsors. Well said.
There you go. Okay.
Well said.
And so, they asked us, come on, you guys must have some information about just hydrogen alone. How does that look? Yeah. Because we have failure models, we got the failure data, and we hadn't really looked at that closely, and they challenged us, and good on them. Because we took a close look at it and said, oh, that's interesting. I mean, it'd be great to have all 9 gases, but 9 gas monitors are pretty expensive, you know, and there's been some, you know, you have to maintain them and everything else. And there's a model here that actually works. You know, it's not as 100% effective, but it's highly effective. And if you do the economics of it, wow, you can actually start monitoring a lot more transformers for a given bucket of money.
They're going to love you. I mean, they're going to absolutely love you at H2 Scan.
Oh, well.
Because that's part of the thing that their thing is. Look, yeah, but anyway, go ahead.
Yeah, well, they wish I'd say hydrogen everywhere. But,
I know, but you won't say that.
We won't, because there is a place for large,
absolutely.
large, you know, multi-gas monitors and then the in-between. We've discovered, so, you know, the different permutations and combinations of gases, they all have different characteristics in the models, and they're all valuable. But the hydrogen, you know, doing that by yourself is clearly the most economical piece.
Yeah. The word research, Delta X, because I always knew Delta X is, you know, TOA4. I knew Delta X, right?
Yes.
And then you and I, we were talking somewhere, and I said Delta X, and you looked at me and you said research. So I remember that. Tell me about that part of it, because that's fascinating. That is not the Delta X I knew. Research means you're using all that science, you're using all that data, you're using it to do something beyond. I think that's the best way I can put it. But tell me about the research part of Delta X.
Well, that's the important part. You know, Jim's a scientist. He's a mathematician. You know, and we have 2 scientists. Zach, I don't know if you've met Zach. He came out straight out of his PhD in astrophysics. He's an astrophysicist.
Oh, I did meet him, the astrophysicist, Zach.
Yes.
Yeah, I did.
Yeah. And he did that at University of Victoria, and he wanted to stay in Victoria. There weren't. We actually do have an observatory in Victoria, but that's a whole other story. But he wanted to do something useful, and he walked in the door one day, and wow, okay, really smart guy, really nice guy. And the first job I actually needed him to do was tech support, because we needed to fill that function. And he was wonderful with the customers, and it was a great learning opportunity for him. He took all that knowledge and is translating it into useful solutions. He's building relationships, getting more data, giving them feedback in terms of what it means. And so, you know, we're 14 people, 2 are committed scientists, you know, separate from development. And we continue to dig into the data, collect more, and build more failure models and figure out exactly what it's telling us so that we can share it with all of our customers.
Brilliant.
You know, so you know, part of my job was build the brand, you know, and as you said, almost nobody even knew Delta X. They all knew TOA4 at the time, right?
Yes, we did.
Right? Said, who are you? Delta X Research, huh? TOA4? Yeah. Right? That's how that went.
We use you.
That's right. Exactly. And so part of it is building up the name and recognizing that there's other companies out there called Delta or Delta X, and that we lead with science. You know, I drive my team crazy. I said, Delta X Research. Even my team, I have to remind them.
Good. I'm glad you're doing it to other people then, too.
Yes.
Good. John, it has been a delight. It's good to see you again, my friend. I hope to see you at the IEEE Grid Edge in April. Are you coming to that?
No, I don't think we're going to be at that one yet. I'm not sure we're an edge technology yet, but I look forward to hearing about that.
You are an edge technology. You're a utility technology that's an edge technology. But anyway, thank you so much. I appreciate
Thanks
it.
for having me.
This has been an APC Technologies production, and we thank you for joining us. Our sponsors have been H2 Scan and Distributech. And of course, the communities of APC Technologies, which is Transform Technology, Power Systems Technology, Green Energy Technology, and Women in Power Systems. So thank you.